Lesson 30, microeconomics and total revenue curves and average revenue and marginal revenue curves. So we're just looking at revenue curves. In the previous lesson, we've looked at cost curves and how the marginal cost curve always goes through the average total cost curve, how that always goes to the bottom there, and the law of diminishing returns sets in here because this is also related to marginal product and average product. And when the average product starts to decline, then the average total cost line here will also start to rise. Logically, you know in your own mind that that makes sense. We also looked at the long run average cost curve, the LRATC. This is the minimum efficient scale, and we discussed the idea that some firms have got to be very, very large, like the car making firms, to achieve the minimum efficient scale. And we've also looked at the fact that the airline industry has got to be absolutely huge, which is why we only have two really, really big aircraft manufacturers in the world today in terms of producing big aircraft. So we looked at all this, and then next session we're going to look at profit, and total revenue is equal to profit. Sorry, total revenue minus total cost is equal to profit, although an economist's profit is slightly different because they also take into account opportunity cost as well. Okay, so this is this bit on here, and if I can find my board cleaner, I'm just going to wipe those off just to clear the board up a bit, because what we really want to do now is look at, there we go, look at revenue. So I just wanted to focus on revenue, and this is a pretty straightforward lesson. Obviously when you get the revenue lines on and you get the total cost line on, or the average total cost line, we can start to work out profit and everything else. Okay, so here we have price 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. A pretty sort of straightforward example really, and this is quantity demanded. So what we're saying is, as you sell more, you've got to reduce your price by £1 each time, which is pretty nutty. Okay, however, that's the way it goes. So they have asked you could have to work out the numbers. So total revenue here is just 1 times 10, 10, 18, 3 8s are 24, 4 7s are 28, 5 6s are 30, 6 5s are 30, 7 4s are 28, 8 3 8s are 24, 9 2s are 18, 1 10 is 10, and 0 times 11 is 0. Okay, so that's your total revenue curve on there. Price times quantity. To work out the average revenue, you just do total revenue times quantity. So 10 divided by 1 is 10, 2 divided by 18 is 9, 24 divided by 3 is 8, 28 divided by 4 is 7, 6, 5, 4, 3, 2, 1, 0. Now what that means is actually the average revenue is the same as the price. Okay, so when we draw a demand curve, the average revenue is exactly the same, and then we can draw marginal revenue on there, which is the difference between the total revenue each time. We've got marginal revenue on here. Marginal revenue is the addition to total. Hey, that is weird. Total. The addition to total revenue as a result of selling one more unit. Right? I came in this morning and I put this on the board at 6 o'clock, which is probably why I put the word total wrong. Anyway, total revenue. So total revenue all the way down here. Right, the marginal revenue here, as I walk over my mic line, is 10, 8, 6, 4, 2, 0, minus 2, minus 4, minus 6, minus 8 probably, and there isn't one there. It doesn't make sense. Right, yes it does. Minus 10. Okay, so there we have the marginal revenue. The marginal revenue is the difference between the total revenues each time. Now, in economics, you maximize profits where MC is equal to MR. I can remember I just learned that, but it's MC is equal to MR. Now that's the traditional theory of the firm, and that's the idea, because we are rational, and therefore if you're in a business you want to maximize profits. Do you remember doing all that behavioral theory? Yeah, obviously in business what do you want to do? Maximize profits. That makes sense. Now if we draw these on a curve, so if we draw these on here, so this is a marginal cost curve and then is marginal revenue. Right, so this is the point where we maximize our profits at this point here. Right, the marginal cost is greater than the marginal revenue is greater than the marginal cost. So we'd be better off by increasing the output to there and here. To the right of this point here, the marginal cost is greater than the marginal revenue. So we would be better off at decreasing output here. I just want to show you that because when we start to put all these lines together, you know where they all come from. Right, how does that then work? When we draw the lines, the marginal revenue curve is always twice as steep as the average revenue curve. Now, when I used to do economics when I was 16, 17, whilst I was still at school, which didn't last a long time. Sorry, just have a cup of coffee. When I was still at school, I just learnt it. You know, I just knew the marginal revenue is twice as steep as the average revenue curve, and then you just draw it. In fact, when I did the cost lines, I just learnt those as well and put them all together. But let's learn it properly. Right, because it says in the notes that you may need to work out revenue curves and everything else. Right, so it's twice as steep. When the marginal revenue is 0, right, that is when you maximize your total revenue. Okay, so you maximize your sales revenue there. So you get sales max there, but you maximize your profits when MC equals MR. Please note, when the marginal revenue curve here at 0, that is where you would maximize your total revenue. On there. The other big thing is when the MR is 0, that's when the elasticity is equal to 1. Okay, above that point, the price elasticity of demand is always greater than 1, and below that point is always less than 1. Right, and if you can just go back and think a little bit again, so let's just draw this on here very, very quickly. Right, if you have an elastic demand curve and you reduce price, elastic is always greater than 1. Which is greater than 1. If you reduce price from there to there, what you're going to find is that your total revenue will go up. Okay, so in this case, if we reduce price, our total revenue will fall. Let's just try that on here. So here we reduce price from 10 to 9, so our total revenue at 1 is 10, and when we reduce it to 9, our total revenue is now 18. Correct. So that means it's elastic. Let's just put in the elastic formula, which is percentage change in quantity demanded divided by percentage change in price. So the percentage change in price here is 10 to 9 is 1 divided by 10. So the price has gone up by 10%, but demand has increased by 100%. Right, so it's gone up, gone down, sorry. Price has gone down, isn't it? Demand has gone up. So there the price elasticity demand is 10. Well, that is clearly elastic. In that case, it's very, very elastic. Let's do it again. So we reduce the price from 9 to 8, and hey presto, total revenue has also gone up, right? Once we get beyond that point, which is here, so let's go from 4 to 3. So then there's been a 25% fall in price. 1 divided by 4 is 25%. Right, at the same time, the quantity demand has gone up from 7 to 8, which is a seventh, which I can't work out, which is roughly maybe about 14%. So there, 14 divided by 25 is whatever it is, 0.68 or something. I don't know what it is, I just made that up. But it's definitely less than 1. Okay, so that is total revenue. That is total revenue. Demand is equal to average revenue, and the marginal revenue, that's how you get it. Now, there's a thing called perfect competition, which we haven't covered yet. But in perfect competition, the demand curve is totally flat. So if you think about it, every time you sell a product, so that's 10 quid, one product you get 10 quid, you sell 2 products, you get 20 quid. If you sell 3 products, you get 30 quid, you sell 4 products, you get 40 quid. And then the average revenue is equal to the marginal revenue, and then the average revenue is equal to the marginal revenue, right? Now that's really good because you maximize profits when MC is equal to MR, correct? Which is, surprise, surprise, there, okay. The other bit also about perfect competition, in the long run, you produce at the bottom of the ATC curve, while those places coincide with each other, and that is the point of productive efficiency. And also price, which is 10 quid, should be equal to marginal cost, which is also 10 quid. And at that point, we're also allocative efficiency. So perfect competition is allocatively efficiently, efficiently is allocative efficient, productively efficient. And it's also the place where MC equals MR, which is the rule of profit maximization. Okay, so we've now done a full session on the revenue curves as well. Thank you.